I'll just solve random questions, okay? So from different areas, mathematics, okay? If that interests you, let's get into it. So let's start with these two. Then we'll look at more and more problems, okay? This one says solve each of the following equations, basically, okay? So let's start with the first one. So let's write our solution here. This is the same as 7x over 3, okay, minus 8 equals to 6 plus 1 times x becomes x over 3. Okay, now when we look at this, we have a denominator here. Okay, so let's make all of them fractions. So we divide this by 1, divide this by 1. Now that we have all of them in fraction, in the form of fraction, let's find the LCM. But we want to save our time instead of doing it the traditional way, wherein we find the LCM. So once you know that the LCM here is going to be 3, multiply this whole equation, okay, by 3. So what do I mean by that? You say 7x over 3, you multiply this by 3, minus 8 over 1, you multiply this by 3, equals to 6 over 1, you multiply this by 3, plus x over 3, multiply this by 3. That's how you get rid of the denominator. Okay, easy. So now this and this cancel, you're left with 7x here minus this and this gives you 24 equals to this and this gives you 18 plus this and this cancel, you're left with x here. Okay, so now we collect like terms. If we want to get rid of the 24 here, we add plus 24 here, then we add 24 here. This and this goes to 7x minus 0 now, okay? So that's just 7x, and this again 18 plus 24 plus x. Now if we want to get rid of this x, we say minus x here, and we say minus x here. Whatever you do on the left, you do it again on the right, okay? So this and this cancel, this and this gives you 6x equals to, you add this and this is 12, 2, remainder 1, this and this gives you 42. You are in need of x divided by 6. This by 6, this and this goes, so my x equals to, if you divide that gives you 7. So therefore, your x value is 7. Easy. Okay? So let's look at the next problem. The next question says, so for this one, we clear the bracket. We say 5 minus times plus is minus, 3 times this becomes 3k. Okay, minus times plus is minus, 3 times this becomes 3 equals to minus k. This is easy, right? So now we collect like terms. If we want to get rid of this one here, we say plus 3k, and whatever we do on the left, we do it again on the right. This again plus 3k. So this and this cancel. You're left with 5 minus 3 equals to this is the same as 3k minus k. Okay, this and this gives you 2 equals to, if you subtract this, it gives you 2k. You're in need of k, divided by 2, this by 2, this and this goes. So therefore your k equals to 2 divided by 2 becomes 1. Okay, so that is very easy to do. Now let's get into more interesting areas. Okay, so let's say if you are asked to prove that sine square x plus cos square x equals to 1. Okay, let's say you're asked to prove this one in exams. What do you do? Easy. Just draw a right angle triangle. Okay, so you have a right angle triangle this way, Then this is 90 degrees here, and you have the angle here, which is x. Now label this one. This can be A, this can be B, this can be C. Okay? There are two things you need to know here. You need to know Pythagoras theory and the trig functions. Okay? So for Pythagoras theory, it says in a right angle triangle, the longest side, which is this, the hypotenuse, okay, which is b square, the square of the longest side is equals to the sum of the squares of the two remaining sides. So this is the hypotenuse. The square of that equals to the sum of this, the sum of this. Okay. So this is Pythagoras theory. Now the next thing you have to know is trig functions. Okay. So for trig functions, if this is the angle x, you can say sine x equals to the opposite over the hypotenuse. How do you know which one is the opposite? See this angle, the opposite of this angle. So this is O, this is H, and this is A. A is the adjacent, hypotenuse, and this is the opposite. So that's sine. So and cos again is equals to the adjacent over the hypotenuse. Where do we get this one? Well, we got this one from Sonkatua. Okay, it says SOH CAH TOA. Okay, so that's Sonkatua. Sine, which is opposite hypotenuse, cos adjacent hypotenuse, tan opposite adjacent. Okay, so that's it. But we are not going to talk about tan here because we don't have tan. Now let's see. So if we now know this one, what is the opposite? The opposite is A. The hypotenuse here is B. This again, the adjacent here is C, and the hypotenuse is B. So let's just keep that. Now let's prove. We say sine square x plus cos square x. Let's focus our energy on the left hand side. This is the right hand side. We want to prove whether the left hand side is equals to 1. So what is sine x? Okay, sine x here we say is A over B. Okay, but this sine has a square, so you square this plus. Now cos square x, this again the same as C over B all square, right? Now as you can see, the bracket has a square, so this means this is same as A square over B square plus this again C square over B square. If you are finding the LCM here, is B square, that is the common one. Now once you know that B square into B square is 1 time, 1 multiplied by A square becomes A square plus this into this is 1 time, 1 multiplied by this becomes C square. Now once you have this, what do you notice? You go back to Pythagoras theory. Pythagoras theory says that B square equals to A square plus C square. So the whole of this one at the top is B square. Then you divide this by B square. B square into B square becomes just 1. So therefore, if the left hand side is 1, the right hand side is 1. Hence, this is, you say, quite easily done. So that's how you prove that cos square x plus sine square x is equals to 1. Okay, let's look at more questions. So this question says a line goes through point 2, 6 and is perpendicular what's that, through the to line 4y plus 2x plus 18 equals to 0. What's the problem there? Okay, solve the equation of the line. Solve the equation of the line. Okay, so this is the question. Let's solve this one quickly. It says a line goes through the point 2, 6 and is perpendicular to the line 4y plus 2x plus 18 equals to 0. Solve the equation of the line. They need us to solve the equation of the line with this point. Okay. Now, one thing you should know what are perpendicular lines. So what this one is saying, you have two lines. Let's say this is line 1. Okay, and you have another line here which is perpendicular, meaning from 90 degrees. This is line 2. But line 2 now has equation 4y plus 2x plus 18 equals to 0. While this one just has point 2, 6. Okay, so this is the x and this is the y value. So you have like 2, 6. So you have this line, maybe it goes this way, something like that. Okay, so now this one has points and this one has equation. They form perpendicular lines. Now they are asking us for us to find the equation of this line. How do we do that? The first thing you have to know, you need to know what are perpendicular lines. Okay, for two lines to be perpendicular, the product of their slope, okay, must equals to -1. So let's say if the slope of this is m, the gradient here, this is m1, and the slope of this is m2, it means that for two lines will be perpendicular, m1 multiplied by m2 must equals to -1. Okay, that is the criterion you need to satisfy. Okay, the product of these two must equals to 1 if two lines have to be perpendicular. Or you can say the slope of line 1 is equals to the negative reciprocal of the other. Easy as that. Okay, so that's how you know that two lines are perpendicular. Once you know that, this becomes easy. First of all, we have to find the slope here. So we are given for line 2. Okay, say line 2. Line 2 has 4y plus 2x plus 18 equals to 0. Now, for you to find the slope from this line, you have to change this equation to slope intersect form. Okay, slope intersect form has equation y equals to mx plus c, where y is the equation of the line, m here is the slope, that is the coefficient of the x, and c is the constant. Okay, that means it's the y intercept. So we need to find this m. Okay, so let's write this one in this form. How do we do that? We have 4y plus 2x plus 18 equals to 0. Let's transpose this. We transpose this one. We'll make 4y here equals to, this now equals to 0. Here minus 2x minus 18. So this becomes 4y equals to, this everything here becomes minus 2x minus 18. Right? Now, but we need y. Remember, look at it here. It says y. The coefficient here has to be 1. So what do? You divide this by 4, this by 4, and this again by 4. This and this goes to your y equals to 2 here, 1. So this becomes minus x over 2. Okay? Then this one, even if you don't reduce that, just leave it like that. So you can just say 9 over 2. But our interest here is this one, is the coefficient of x here. That should be your interest. That's the m, which we are looking for. Okay, so meaning from this, your m, which is the m2, because this is the equation of line 2, m2 here, the coefficient, I mean the gradient here is minus half. Okay, now that you know the coefficient, I mean the gradient for line 2 is minus half, we can easily find the gradient of line 2, which has this point. Okay, easy. So I'm just taking this one off. Okay, I can just take this one. So remember, I told you for two lines to be perpendicular, their gradients, the product of their gradients must equals to minus 1. We've gotten the gradient of this, which is minus half. Multiply by m2 equals to minus 1. Okay, this is easy. This minus cancel this minus. So this is like m2 divided by 2 equals to 1. If you divide that by 1 equals multiply. 1 multiplied by this becomes m2 equals to 2. So hence, the gradient of the other line is 2. Remember, I told you that in another form, or the other way for you to say this one, you can say for two lines to be perpendicular, the gradient of the first one has to be the negative reciprocal of the other one. So easy. So now that we have this line, which has this point, and we now know its gradient, we can form the equation which we are asked to find, solve the equation of this line. Okay, now let's go back. Let's keep these two. So m1 actually should be m1. This was for m2. m1 is 2, right? That's the gradient. Now when we have 2 points, there's a general form for the equation of the line, which is y minus y1 equals to m into x minus x1. Easy. Okay, so this simply means, you see the y1 and x1 here are these points given here. Okay, easy. And these are just functions. So now we have y minus y1. So this should be just m1. Okay, y1 is 6 equals to m1 is 2 into x, this you need that, minus x1 is this 2 here. Okay, so we are now heading to getting the solution of the equation of this line. So now we can just say y minus 6 equals, you distribute these two, this time this becomes 2x, and this is minus 4. Okay, you can write this equation in slope intercept form if you want, or you can just write it in this form, just like the other line. Okay, if we want to write it in this form, we have to bring everything here on the left hand side. So this becomes y, remember, minus 6. Now if you are bringing this becomes minus 2x. If you are bringing this becomes plus 4. Okay, everything here now equals to 0 because you've transposed everything here. Okay, so this becomes y, this is minus 2x, minus 6 plus 4 becomes minus 2 equals to 0. So you can write it this way, which is correct, or if you want to write it in the slope intersect form, which is, so let me just take this one, which is y equals to mx plus c. If you want to write it this form, you transpose these two here. Okay, so you have y equals to, this is minus, if it's going over the equals to sign changes to plus, and this again is minus, when you transpose it becomes 2. So this is its slope, and this is the y-intercept. Okay, easy. So let's just keep solving. I'm just solving random questions, you know. Easy. So that is it for perpendicular lines. For two lines to be perpendicular, the product of their slopes must equals to -1. Okay, what about parallel lines? Okay, how do you determine two lines are parallel? Well, for two lines to be parallel, their slopes must be the same. That is it. Okay, so let's say if you have y line 1 has equation y equals to, let's say this is 2x plus 4, right? they can write it in different form. Then line 2 equals to, let's say this is 2y equals to 4x minus 3. If you look at these ones, their slopes are the same. How do you know? Well, first of all, let's write this one in terms of slope intercept form. So for us to do that, we always have to make sure that the coefficient of y is 1. Right now, it is not 1, so you divide it by 2, this by 2, this by 2 throughout. So this and this go. So y equals to, if you divide this, becomes 2x minus 3 over 2. Forget about this one. Your focus should be on the coefficient of x. The coefficient of x is 2. The coefficient of x is 2. So it means that these two lines are parallel. Very easy, easy. Okay. Anyway, so let's solve another question. Let me see. So this one says solve for the x-intercept of the second derivative function. Okay. Solve the x-intercept. Solve the x-intercept. So that means there are two of the second derivative function. So we are given the function. It says x raised to the power 4 plus 4x cubed minus 18x squared. Okay? So that is the question. We are asked to solve the x-intercept of the second derivative of this. Okay? So now, for us to get the x-intercept of an equation, the y has to be 0. So basically what this one is saying is like you're having y equals to x raised to the power 4 plus 4x cubed minus 18x squared. Okay? For you to find the x-intercept, you equate the whole of this equation on the right hand side equals to 0. So meaning you make this one 0, basically. Okay? Just like graph. Let's start with the basics. If you have 2x plus 3, if you want to find the x-intercept here, what do? You equate this to 0. So now you have 2x plus 3 equals to 0. You transpose this, so you have 2x equals to, this becomes minus 3, divide by 2, this by 2. That's how you find the x-intercept. Easy. Okay? So let's don't complicate things here. So now that you know this has to be 0, so let's write it now in that form. X raised to the power 4 plus 4x cubed minus 18x squared equals to 0. But remember, it says solve the x-intercept of the second derivative function. Okay? We have to find the second derivative here. Second derivative. Meaning you differentiate this function twice. That is it. It's so easy. Okay? So for you to do that, now differentiation is very easy, right? You multiply this power by the coefficient of the variable, which is x here, and subtract 1 from the power. That is how you differentiate. Okay? This is like differentiating sum or difference. So this and this becomes 4x cubed. Remember I told you multiply this, then you subtract 1. Then you come to this next one, plus this and this gives you 12x squared minus this and this gives you 36x. 2 minus 1 becomes 1. Okay? Everything here equals to 0. Easy. So this is the first differential of x. Okay? So you can say dy over dx. Now the next one is d square y over the x square. This is the second, or you can say f double prime of x. Okay? Now let's differentiate this function again one more time. Easy. So this again becomes 12x squared now. Okay? Then this now becomes 24x. Now this becomes minus 36. How do you know that? The power of this is 1. You multiply it, gives you 36, right? Remember the power of this is 1. 1 minus 1 is 0. Any number raised to the power 0 is 1. So hence x here becomes 1. 36 multiplied by 1 becomes 36. Everything here equals to 0. Now all we have to do, we just have to reduce this one. This is now quadratic equation. Okay, we are in the highest power of x or any variable is to the degree of 2. Okay, which is this. So now we can solve this one. But if you look at this one, there's something that is common here, which is 12. 12 can go divided by 12, this by 12, this by 12, this by 12. We reduce this equation. Okay, we don't have calculators. So this and this becomes x squared plus this is 2x, and this is minus 3 equals to 0. Now you can easily solve this one. For you to solve a quadratic equation, you look for the coefficient of this, which is 1, multiply it by the constant. So you multiply this, okay? That becomes minus 3x squared. Now your aim is to look for two numbers that if you multiply them, you have this product. If you add or subtract those two numbers, you should have positive 2, the middle term here. And those two numbers will be 3 and minus 1. Easy. So 3 comma minus 1 are the two numbers. Because if you subtract these two, you have positive 2, which is this. Remember, I told you can get this one by either adding or subtracting. Okay? Now, when you multiply these two, you have minus 3, which is again this minus 3. So now that you have the two numbers, let's solve now. So first, you maintain this one, which is x squared. Now, this plus 2x is these two numbers. So you can either say minus x here, which is this minus 1, or you can say minus 1x, then plus 3x. So minus x plus 3x gives you this plus 2x. So you don't need to write this again. Then minus 3 equals to 0. Okay. Now you have 4 different terms. 1, 2, 3, 4. You factorize them. Okay. So you group this one in 2. Okay. Now you look at this part. What is common here? X. If you take one x out, what remains another x here? Minus. Now you've taken this x out. What remains here is just 1. Remember the coefficient of this is 1. Plus. The same thing, what is common here is 3. You take it out. What remains there is x minus. You've taken this 3. What remains there is 1 equals to 0. Always these two must be the same. Easy. Okay? So now, if you look at this, look at this part. What is common here is x minus 1. So if you take x minus 1 in one bracket, you open another bracket. What remains here is x plus. What remains here is 3 equals to 0. Now all you have to do is to solve for the values of x. Okay. So x can either be, let me just take this one at the top here. Okay. Easy. So you have x minus 1 and x plus 3 equals to 0. So you solve for this, you equate this to this. So you have x minus 1 equals to 0. You add plus 1 here, you add plus 1. This and this goes, so your x equals to positive 1. Or you can say x plus 3 equals to 0. You minus 3 here, minus 3 here. This and this goes, so your x equals to 0 minus 3 is just minus 3. Therefore, your x-intercept will be 1 and minus 3. These are your two intercepts. Okay, so if you have a graph, you have y-axis and x-axis. It means these are the intercepts. You'll have like this one, and the other one will be minus. Let's say this is minus 3. Okay, so maybe you have a graph going this way. This is the x-intercept. You have another graph from this one going this way. Okay, let's say this is 1. This is the x-intercept. Okay, or maybe because this is quadratic, so it's going to be like this, basically. Either a parabola, okay, or hyperbola graph, quadratic graph. Easy. Okay, so let's solve another question. This is easy. The next thing, let's do differentiation. We've done differentiation already, so let's do one more rule, which is chain rule. Let's solve one problem on chain rule. So let's say if you're asked to differentiate with respect to x, differentiate with respect to x, y equals to x plus 4 all raised to the power 3. So we are given this one. We have to differentiate with respect to x. So if we ask to differentiate this with respect to x, easy. So the rule we have to apply here, we apply the chain rule. Okay. The chain rule says that dy over dx equals to, so this is like you have dy over du multiplied by du over dx. So if this and this cancel, you are still left with your dy over dx. Okay, easy as that. So let's go. Now, the first thing you have to do here, you let this one to be u. So you let u equals to x plus 4. Okay, x plus 4. Easy. Now you differentiate u with respect to x. So you say du over dx equals to, when you differentiate this one, it becomes, you remember 1 multiplied by this becomes 1 here. Then 1 minus 1 is 0. Any number raised to power 0 is just 1. So if you differentiate, this becomes 1 plus 0. So therefore, your du over dx becomes just 1. Okay? Easy. Now, once you know that, remember, you've let this one to be u. So your new equation y equals to now u raised to the power 3. The whole of this is u raised to the power 3. Now, let's differentiate y with respect to u. So you say dy over du equals to, you differentiate, it becomes 3u square. Okay? Easy. Easy. So once you have this one, what do we do next? We apply the formula. Remember, I told you is dy over dx equals to, you say dy over dx equals to, dy over du is what? 3u square. Multiply by du over dx is 1. This is just 1. Easy. Okay? But we don't need this u here. What do we need? We need x because we are differentiating y with respect to x. So say but u, which we let to be what? What was u? X plus 4. Replace that, this becomes dy over dx equals to 3 into, what is my u? Is x plus 4, then u square, right? Multiply by 1 is just the same. So hence, that becomes your answer, right? It's so easy. Okay, so that is it. Let's solve another question. Let me see. So let's see. We are asked to simplify, solve for x here. So we are asked to solve for x. This is easy. Okay. Now, the first thing you should be able to identify here is realizing that this has a square root, this has a square root. Since the numerator and the denominator do have square root, what do? We just put them together and give them one square root, okay? Because that is common. So this becomes the square root now of 4, 3x plus 1 divided by 4 again, 2x plus 1 equals to 2. Okay? Now, from this, what do? Focus on this. Forget about this square root. Focus on this. Indices. When the base are the same, you take 1. If it is division, you subtract the powers. Easy. So this becomes square root. Then you have 4. We take 1. Then you have 3x here plus 1 minus. Now you bring these two. So you open a bracket, you say 2x plus 1. You close bracket. Everything equals to 2. Easy. Okay? Now let's deal with this. This becomes square root 4. This is 3x plus 1 minus 2x minus 1 equals to 2. So now becomes square root 4. This and this becomes x. This and this cancel because this is plus 1 and that, right? Yes, so everything becomes 2. Now, how do we get rid of this? We square here. Then whatever we do on the left, we do it again on the right. So this and this goes, you are left with 4 raised to the power x equals to this again becomes 4. Now, in this is again all exponentials. When you have the base the same, here you cancel them and equate the power. So the power of this is 1. If you cancel this and this cancel, so my x equals to 1, which is your answer for this question. Okay, we are asked to solve for x. Let's do more and more problems, right? Yes. If this question says if roots 5 minus 3 divided by 2 roots 5 plus 3 equals to x plus y root 3. Okay, root 5. Find the value of x plus y. Find the value of x plus y. Okay, easy. So let's do that. Okay, so we are given if root 5 minus 3 divided by 2 root 5 plus 3 equals to x plus y root 5. Find the value of x plus y. This is oh my god, Surds. Okay, so let's deal with this one quickly. Now focus your attention on the denominator here, which is 2 root 5 plus 3. Now for us to solve this, we apply two things. We rationalize the denominator, meaning you multiply this denominator both at the top here and at the bottom. That's the first thing. Then, but before that, you have to find the conjugate of this one. Conjugate. The conjugate of this, meaning you have to find the opposite of this basically. So this becomes, the conjugate of this becomes 2 root 5 minus 3. You just put a minus basically. That's it. Okay. So now, once you have this, you multiply the conjugate now. So this becomes root 5 minus 3 divided by, this is 2, this one first, root 5 plus 3. Then you multiply this by the conjugate, which is 2 root 5 minus 3 divided by 2 root 5 minus 3. Okay? That is it. So now, let's just multiply. Multiply this by this. So this becomes root 5. You open brackets, 2 roots 5 minus 3. You close bracket, then minus this 3. Then you open another bracket, you write again 2 roots 5. Okay. 2 root 5 minus 3. So that's it. Then divided by. This again the same thing. You take 2 root 5. You open bracket, you put this one. 2 root 5 minus 3. You close bracket, then plus 3. into 2 roots 5 minus 3. So now let's just